Hi, in this video we're going to look at integration dealing with natural logs. Beg your pardon. As before, we're going to look at developing a method to try and find this integral, and we're going to look and see how that plays out with both indefinite and definite integrals. Hopefully you'll remember the formula that we've used when trying to find the derivative of a natural log. And I give it to you there. The derivative of the natural log of some function f of x is going to be a fraction. First of all, we're going to find the derivative of that function, and then we're simply going to place it over the function itself. So if I take this first example here, the derivative of ln x, well, I find the derivative of x, that is just 1, and I put it over the function, which is just x. So the derivative of ln x is 1 over x. If I come to this example here, the derivative of ln of 3x, well, I'm going to look at deriving 3x. Derivative of 3x is 3, and I'm going to put that over 3x, and that too will simplify down to 1 over x. Third situation, if I go and find the derivative of the ln of 3x plus 1, I need to derive that part over there. Derivative of 3x plus 1 is simply going to be 3, but my denominator this time is going to be that function 3x plus 1. And so there is the derivative of that particular function. Now, as I said earlier, we've got to remember that integration and differentiation are inverse operations. So I can differentiate something and it becomes a particular function, but then I can also go and integrate that function back in order to find what the original derivative was. So if we go and look at these options here, what did I derive in order to get 1 over x? Well, if we remember that I derived ln x to get 1 over x, then I'm going to say, right, well, that's simply going to be the ln of x plus c. What did I derive to get 1 over 3x dx? Well, this is slightly more complicated, and we need to think about this in a little more detail. When we looked at deriving, we used this formula over here. We ended up having the derivative of the function up on the top and the actual function down at the bottom of the fraction. That was the answer when we derived something, when we derived a natural log. Now, in this particular situation over here, the top isn't the derivative of the bottom. However, I can manipulate that. I could say that my top is going to be a third times 3 over 3x dx. Now I can take out that 1/3, and I'm going to be left with the integral of 3 over 3x dx. Now the top is the derivative of the bottom, and that allows me to say, okay, well, that means I'm going to have the ln of 3x, not dx, plus c. Remember, I've got to ask myself, what did I derive to get to my function that I'm trying to integrate? So likewise, in the next example, it looks like it's going to be a natural log answer, because I've got this fraction. However, once again, the top is not the derivative of the bottom. So again, I'm going to take this trick of writing that 1 as a product of 3 times a third. And that I'm going to write as 1/3 the integral of 3 over 3x minus 1 dx. And so that's going to give me an answer of 1/3 natural log of 3x minus 1 plus c. So, having seen the relationship between the numerator and the denominator of the answer of our derivatives, we need to be aware of that when we look at an integral. So, if we have a situation where the numerator is the derivative of the denominator, then we know that we're going to be working with a natural log situation. So there's our formula, and we're now going to look at some examples. Now, in fact, that formula is not exactly correct. We do need to be a little bit more careful about that. We know that for a natural log, the natural log is only going to be defined when x is greater than 0. So we don't want whatever we have inside over here being something that's less than 0, in other words, being negative. So to take care of that situation, what we do is we put an absolute value sign around that function f of x to ensure that we're talking about the ln of a positive amount, a positive function. So here are some examples that we're going to work through. The integral of 4 over 4x. Well, that's going to simply be the ln of 4x plus c. But I must make sure that I put an absolute value sign in front of that. The integral of 1 over 3x dx. Well, as we've done before, that's an integral of a third times 3 over 3x dx, and that's going to give me 1/3 the natural log of 3x, absolute value of that, plus c. This one over here, possibly a little bit more complicated. The top isn't the derivative of the bottom, but it is a straightforward number. So what I could say is, okay, well, if I'm wanting to have on the top line, I want to have the number 6, so that I can say that the top is the bottom, the derivative of the bottom. But what must I multiply this by in order to get 5? Well, I must multiply that by 5/6. 5/6 of 6 is simply going to be 5. So I'd use that little manipulation. I take that out in front of the integral, and I'm now going to say this is the integral of 6 over 6x dx, and that means I'm able to get to my answer of being 5/6 natural log of 6x plus c. And finally, to round something off, we'll look at a definite integral. So here we've got the definite integral between 0 and 2 of 1 over 5x plus 3 dx. As we've done before, we're going to write this as the integral between 0 and 2 of 1/5 times by 5 of 5x plus 3 dx. So that's going to be 1/5 the integral between 0 and 2 of 5 over 5x plus 3 dx. And so what do we have now? We have 1/5 of, put in square brackets, the natural log of 5x plus 3, and that's going to be between 0 and 2. So I have 1/5 of the natural log of 5 times 2, which is 10 plus 3, natural log of 13, plus the natural log of 5 times 0 plus 3 is going to give me 3. And obviously I can combine those two, and that's going to give me the natural log of 13 times 3 in other words, 1/5 the natural log of 39. And I can leave my answer like that. That's a nice exact value. Right, hopefully it all makes sense to you. You now need to go and practice it. Goodbye.